Visitors discover the streppy-thieu double-boat lift for the first time. The dimensions and the architectural majesty of this imposing engineering structure intrigued them. This feeling then gives way to the twofold question: what is it used for, and above all, how does it work? The answer to the first question is a very simple one. Like a traditional lock, the purpose of the lift is to enable vessels to overcome a difference in level on the waterway, whether the vessels are travelling upstream or downstream. We should point out straight away that the streppy-thieu lifts are referred to as funicular lifts because they are moved by cables. They are differentiated in this way from the older lifts built on the historic canal, which are called hydraulic lifts because they are powered only by water. In that case, each tank is entirely dependent on the other, unlike the two autonomous tanks that equip the streppy-thieu giant lifts. For the hydraulic lifts, the lifting and lowering operation is simply based on a balancing principle, with one tank being used as a counterweight to the other. The upper tank, made a little heavier by adding a few centimetres of water, goes down, while the lighter tank goes up. Let us make it clear that such a structure was designed to take small 300-ton barges, and that system will prove to be unsuitable for modern vessels weighing over 1,000 tons. As far as the streppy-thieu structure is concerned, the operating principle may be compared to that of a lift in a building. The mobile caissons are two huge tanks, which are operated like a lift shaft. Like a lift, the tanks are moved by cables, driven by a motor and counterbalanced by counterweights, with a practically identical weight, but in this case, it amounts to 8,000 tons. Considering the size of the weights concerned, a considerable amount of machinery is involved, including several motors, several counterweights, and very many cables to operate everything. Furthermore, as we pointed out, each tank is independent and has its own engine room. The boat lifts are equipped with double gates. It is something else that it has in common with a building lift, which has its landing door and its car door. In this case, as streppy-thieu, the landing door is called the reach gate. Its task is to hold back the waters of the canal as long as the lift is not at the same level. This gate is of the lift gate type. It is operated autonomously, driven by a hoisting winch. As for the tank gate, it may be compared to the car door of a passenger lift. This gate travels with the tank as it moves up and down. It is not motor driven and therefore never risks opening accidentally during the raising and lowering operations. The tank gate can only be opened jointly with the reach gate. For this purpose, the reach gate is fitted with rods that are positioned before the start of operations, being fixed under the hooks placed on each side of the tank gate and taking the latter gate by raising it during the opening maneuver. From the start of this operation, the water level of the tank is adjusted to the level of the canal. As the case may be, a little water is let out of the tank, or on the contrary, a little canal water is added to the contents of the tank. note on, the water level in the tank does not change as the vessel enters or leaves. There is no weight change either, since according to Archimedes' principle, the weight of the displaced water is equal to the weight of the vessel. An inflatable seal ensures perfect tightness between the reach and the tank opposite it. It means that the connection is totally watertight and there is no risk of water leaking when the doors are open. When the vessel enters, the two gates of the chamber close again at the same time, and the system of mobile rods folds back, unfastening the reach gate and releasing the tank gate, which can then be raised or lowered with the tank, making it watertight and independent. These imposing tanks have an effective length of 112 metres and a width of 12 metres. They can take a 2,000 tonne or a 1,350 tonne barge, two 600 tonne barges, and, of course, several boats with small tonnages or pleasure or tourist boats. The enormous caisson is balanced by 8 counterweights, each weighing 1,000 tonnes. When the caisson is filled with water to a height of 3.75 metres, that represents an additional weight of 8,000 tonnes. Four of these counterweights travel on the outside between the imposing metal columns guided by a rail. The other four counterweights cannot be seen from the outside and travel inside the concrete central tower. The number of cables hooking each lift is calculated to match the dimensions of the structure. In actual fact, 144 cables with a diameter of 85 millimeters connect each of the tanks to its counterweights. These cables wind onto motor drums and pass through idler pulleys, each of which is 4.8 meters in diameter. The impressive machinery is to be found at the top of the tower in a vast room, 110 meters long, just above the tank. Twin machinery, installed on the opposite and parallel side, operates the second tank in identical conditions. For that reason, inland waterway traffic continues on one or the other bank, even when one of the tanks is stopped for maintenance purposes. From the control room, located at the top of the tower, the lock keeper starts the operation. The entire raising operation of the tank takes place at a speed of 20 centimeters per second, which brings the time needed to raise the tank to a little over 6 minutes. The streppy-thieu lifts mean a considerable saving of time, personnel and energy for inland waterway transport. Modern traffic passing through Wallonia, as well as between France and Germany, is faster and more direct, and therefore improves efficiency.